Thank you for attending this session on simplifying Apache Geode with Spring Data. My name is John Blum. I am a member of the Spring Data team. My responsibilities include things like Spring Data Gemfire and Geode, obviously, as well as Spring Data Cassandra. I also work on Spring Session, so I built the extensions in Spring Session for using Gemfire or Geode as a provider in Spring Session. And I also work on bits in Spring Boot that are related to Gemfire and Geode. So I've been associated with Gemfire and Geode for quite a while. This is a 30-minute talk, and I'll try to move as quickly as possible. And I really appreciate you guys being here because I know it's pretty late in your day. So this is just a quick look back of where we came from, where Spring Data Geode started. Spring Data Geode actually spun out of Spring Data Gemfire originally. So Pivotal Gemfire existed for quite some time, since 2002. And Spring Data Gemfire was the first project. And when the Apache Geode project was conceived or formed, which was back in 2015, we were talking open source back in as early as 2014. But the project became an open source project at Apache Software Foundation roughly February, March, April timeframe. That's when I decided to create the Spring Data Geode branch or fork of Spring Data Gemfire that was specifically catered to Apache Geode. So that was right around 2015. Since then, we've had, well, as you can see, we've had several other releases here, from milestone 1 to 2 to 3, and all those kind of corresponded to Apache Geode releases at that time. And then in 2016 of November, Apache Geode went top-level project. They had their first GA release. Actually, the GA release happened before it became TLP. It was a 1.0.0 incubating, and then shortly after that, it became a top-level project in the Apache Software Foundation. And every single release since GA, it's been in step. Spring Data Geode's been in step with that. However, as of Spring Data K, so if you're familiar with the Spring Data portfolio projects, we actually have what are called release trains, and that's where all the Spring Data portfolio, all the modules participate on a regular release cadence. So there's things like Spring Data JPA, Redis, Gemfire Geode, Cassandra, and a bunch of community modules like Couchbase, Elasticsearch, all that. They all are on step. And as of Spring Data K, Apache Geode, or Spring Data Geode for Apache Geode, joins that release train. So it won't be specifically tied to Apache Geode releases anymore, but it'll be tied to the release train, which has a fairly predictable and regular release cadence. K has been a little unpredictable because we've had a lot of changes in Spring 5, as you know, the reactive stuff to Java 8, a bunch of stuff changed there, and so all the other ecosystem projects like Spring Data, Spring Integration, Spring Social, Spring Everything are all tied to the core framework, and so that we've had a longer release cycle than normal. But the one after this is Lovelace. We name all of our release trains after famous computer scientists, and anyhow, I'll be getting into the Lovelace stuff in a little bit. So the core theme in Spring Data Geode this time has been around simplicity. So I'll take a quote from Alan Kay: "Simple things should be simple, and complex things should be possible." Sometimes something that seems complex is really actually quite simple because it's organized in such a way that it becomes simple to use or simple to understand once you understand that organization. So that kind of basically leads into the 2 points that I want to make about Spring Data Geode. And if you've attended some of my other talks, you've probably seen this slide already, but I've been in 3 talks at this conference, and it's kind of hard to keep all the content quite unique, so I'm kind of borrowing from those talks. But again, for people that haven't seen this talk, so the core theme is really around the simplicity, getting up and running as quickly and easily as possible. That's the first thing. So making sure that there's not a lot of ceremony, a lot of setup or process that you need to do to just get something running that's easy to do. The second thing is making that journey to the cloud. So from my local environment, I want to be able to push things into a managed environment, whether that's an application server or it's a cloud platform that's managed for you like Pivotal Cloud Foundry, or you're pushed into AWS and so on. I want that experience to be the same. So I kind of broke everything down this time around in Spring Data Gemfire, and I decided, or Spring Data Geode, excuse me, and decided how can I make the user's experience simpler out of the box? How can we enable features in Apache Geode to make it simpler to do those things? One of the ways I did that was, well, because both Spring Data Gemfire and Spring Data Geode are part of the release train, I made those dependencies pretty much virtually indistinguishable. So if you want to use Apache Geode, you start in the open source realm, and you want to move to Pivotal Gemfire, it's as simple as switching that dependency. And if you want to go back to the open source, you can just switch your dependency back, and you'll have all the Apache Geode bits. The way that's made possible is Spring Data Geode 2.0, okay, builds on Apache Geode 1.2.1. Spring Data Gemfire 2 builds on Pivotal Gemfire 9.1.1, which is built on Apache Geode 1.2. So that makes things a lot easier when you want to like interchange those dependencies. You'll still notice things residual from Apache Geode that's from Pivotal Gemfire, like you'll see Gemfire class names, and in Pivotal Gemfire, you'll see Apache Geode names, like the org Apache Geode namespace. That's to be understood or expected. And also, that's not going to change, because my goal is that you don't have to change a single import, right? If I want to switch to dependencies, I just switch my dependency in my Maven Palm or my Gradle build file, and I'm done. I can use either one, and that works as of K 2.0. I've already kind of touched on this with being able to move from your cloud environment to your ID and back and forth, or from ID to cloud and back, right? Like I want that experience to be pretty much similar. It shouldn't be any different. Like if I push my application to Cloud Foundry, any cloud environment, I don't really want to have to change much code, or at all, anything, right? The only thing you really should have to worry about is maybe port numbers, configuration parameters, right? But I shouldn't have to change my application. So it's based on some work that I've done in Spring Data Gemfire 2, and even as early as 1.9, but it's based on an annotation configuration model that was inspired by things I've done in Spring Data Cassandra, Spring Session, as well as Spring Boot. And I kind of took Spring Boot's philosophy of convention over configuration. So it provides a lot of sensible defaults for a lot of the Gemfire settings out of the box, or Apache Geode. If you're familiar with Geode, you know that there's a lot of different configuration things that you can do. It's very flexible, right? You can cater to almost any kind of use case that you want. But those configuration settings can get overwhelming pretty quickly when you're trying to find something maybe specific to your use case. So Spring Data Gemfire tries to provide the default settings that make the most sense for your application. And it pretty much uses all the Gemfire defaults. It just hides them for me, so you don't have to worry about it. But it also gives you the flexibility to tweak those things if you need to do that. So that's the overriding and customizing bit. I'm going to show you how that's actually done. But rather than talk about all this, I just want to show you a quick demo. How many people here have actually used Apache Geode? Okay, more hands. You guys don't have to raise your hands. How many people use Spring Data Geode? Okay, awesome. All right, so let's just start with a small demo. I apologize if you've seen this before. That's okay. It gets better in the end because I've actually got a surprise. Let's get rid of that. So I'm going to jump over to my IDE. Let me blow this up a little bit so everybody can see it. Actually, I'm going to wait till I actually create a file. So what I'm going to do is I'm just going to create a small little application where I just need to collect some consumer information, or excuse me, customer information. And I just want to persist that to Gemfire, or excuse me, Geode. If I say Gemfire, I really mean Geode and vice versa. There's virtually no difference there. So as the dependencies would dictate. So let's build a small little application, and I want to show you how quick and easy that can become, and we're going to basically convert it into a client-server application. But first, we're just going to start local. I just want to get something in Geode as quickly as possible. So, and this example has already been complete. That's what the complete is. If you go into the GitHub repository, you can look at it, and then the initial is you can try it out for yourself. But I'm just going to build it here today and walk you through the process of how that would look. So I'm going to create a class for my customer, demo app, demo client, model, customer. Okay? So I'm going to take advantage of some libraries that make it real simple to create a value object or a domain class. I'm going to take advantage of a project called Lombok. How many people here have heard of Lombok? Yeah, Lombok's pretty slick. I like Lombok. At required args, constructor, static name, new customer. So I need an ID for my customer. At ID at non-null. So this is basically just telling Lombok that I'm requiring this to be specified when I create this object. It's part of the args, the required args in the constructor. And I just want to give this customer a name. Okay, so I've already used one of the mapping annotations. This comes from Spring Data. This says, this is the ID, or in Gemfire's case, this is the key. So Gemfire is, or Geode is, a key value store, right? I map a key to a value, which is my object, my customer. So I'm also going to tell it which region I want it to go into. There's another mapping annotation. If you're familiar with JPA, these are all real similar, right? At entity or at table, your at IDs. There isn't as many relations, of course, because this is not a relational model. It's a key value store. So I'm just going to give it customers. There, we're going to write this to a customer's region. And you know what else I'm going to do? I'm going to index this. So there's a new annotation called @indexed that'll actually create an OQL index. So if I query by name, it'll call the index. So I need something where I can actually, I need an object that I can persist this. I need a data access object. I want to be able to write it in there. Spring Data provides a repository infrastructure. That's simple to do. Customer repository. And it's an interface that extends a Spring Data interface called CRUD repository. There's actually several different implementations of repository interface itself. There's CRUD, and what you give it is you give it the domain object you're persisting along with the ID, the type of the ID. And what it has in it is a bunch of, let me expand that, sorry. What it has in it is a bunch of CRUD operations. I can create an object, I can read, find it, find by ID or find all. I can obviously save it, update it, that is, and of course I can delete it. So other types of repository implementations are like paging and sorting. That's not supported yet, but we're going to get to that in a bit. Sorting is supported. So let's just create one particular query method. So in addition to the CRUD operations, it also supplies those simple queries for out of the box. But I can actually define my own queries. And the way I do that is I just say something as easy as customer find by last name. And maybe I want to use a wildcard, so like, string, name. And that's pretty much it. That's all I have to do. And what Spring Data does is actually parses this method declaration, and it says, I'm going to construct a query for that. But not just any query. It constructs an OQL query, because that's what Gemfire understands. And if this were a repository for JPA, it would construct SQL. And if it was Mongo, it would construct the necessary syntax for accessing stuff in Mongo and so on. So this is Spring Data's common infrastructure for doing data access. And I've also built in some extensions, so some additional annotations that I can specify my query methods like limits, specifying imports. I'm not going to get into the details of that. Tracing is a useful one because I can actually spit out when that index is actually used, and it gives me metrics about a little bit of detail about that index when it is used. So I used a trace annotation. And if you're familiar with what OQL is, it actually just adds the trace keyword to the OQL statement. That's what it's actually doing. But I can do this here in my repository. So now I have a repository where I can persist my customer. Let's create an application. And I forgot to add that to a package, so let me do that real quick. Example, client repo. All right, I'm just going to drop that in there. I'll explain why I'm doing that in just a minute. Oh, boy. Cancel. Wrong package. So I used to type an example that I forget that when I'm doing a demo, I use demo. So demo client repo. Okay. Now I can drop that in there, and now we just need a application to run it. Oh, shoot. Do that again. Do refactor. Okay. There we go. That's what I wanted. So now we're just going to create a Spring Boot application. Hopefully everybody here is using Spring Boot. I love Spring Boot. Client application. Okay. Get rid of that. Close that. So how does this work? At Spring Boot application, main method, Spring application, .run, my client application, .class args. Okay, it's not a Gemfire or Geode application yet, so how do I do that? I want to make it a client application. I always start from the perspective of the client, because anything I can do on a server, I can start with my client, and then I can always turn it into a client-server application. And that's what we're going to do, but we're going to start locally first. So all I have to say is client cache application. And that's not a coincidence. I wanted to make it so that it's really comparable to boot, right? I have Spring Boot application. This is a client cache application, and it's specifically an Apache Geode client cache application. And it uses all the defaults, so I don't have to specify anything, but there are a whole bunch of attributes on this guy. If I were to expand that out, there's a whole bunch of attributes in here that you can set, but none of them are required by default, but we're gonna come back to that later. You can even name the client if you want. You can adjust the log level. And right now, this is all hard-coded, but I'm gonna talk about how we can make that dynamic later. Like I can adjust the log level. The default's already set the config. I may wanna turn it up or turn it down. Simple things like that. So we need to enable repositories. You can do this in XML, but it's really easy to do with annotations. So enable Gemfire repositories. Okay. Pretty much all the data stores that support the repository abstraction has this annotation, and they also have corresponding XML config or different ways in which you can enable it. This is the easiest way. And the reason why I threw that repository in a package is I can limit the scan. So as you know, Spring uses component class path scanning to find things on your class path and enable things by default. So Spring Data Geode is no different. It's gonna do the same thing for you. And all I'm gonna do there is I'm gonna specify my customer repository. So that just limits the scan to that package where the customer repository interface exists and all subpackages below that. I also need some place to put my data, right? Because we know that this customer is being stored in a customer's region, or at least instances of customers. So I made that simple to do too. If you have literally hundreds of regions, you don't want to sit there and create all of them, all the declarations. I mean, you only have to do it once, but if you just want to get up and running quickly, you can just say, I enable entity-defined regions. And say, base packages again. You can limit the scan to where your entities exist, or the classes that are storing your data. So now that'll create a region for me. And right now, I just want to make that a local region. So if you're familiar with what Apache Geode can do, it has different data management policies to manage your data on the server as well as on the client. And the default is a proxy. It assumes that you want to connect a client to a server. But if I want to just do things locally, there's shortcuts where you can say, I just want to set this to a client region shortcut of local. Now I just have myself a local region, and it doesn't expect to send anything to the server. Now we need something to basically create a customer, run our query, get the customer back out, right? Put the data into Gemfire, or excuse me, Geode, and get it back out. How do I do that? So I've already baked in a runner, so I don't have to type all this stuff. Okay. Uh-oh. Back over here. New customer. Yeah, that's right. Doesn't like about that. String. No. Log. Oh, my bad. One thing I forgot to do with the logblock at non-null. That tells that it's a required arg. There we go. Now it should like that. Now I can just run this. What else is wrong? Find by name like. Uh-oh. Find by last name like. Yeah, that's not right. There we go. Now we're good. And this should compile. So this is this application runner. This is something that Spring Boot invokes after your application starts up. And all I'm doing there is I'm basically creating a customer object. I'm using the repository, and I can inject that into my method. This is just an @bean. That's a bean, regular bean, like anything else in the application context that Spring Boot recognizes, sees that it's an application runner, runs it, injects any dependencies. So any method arguments is like constructor injection. So then I can use that repository to save my customer, persist the information that I get back out, like everything's still kosher, and then I can run the query. So I've got some print lines there so we can see that happen. So I should be able to run this now. Run. And it works. So everything in red. Hopefully everybody can see that just fine. So now we're done. We're done building this locally. Now I want to move to the client-server model. I want to actually the data doesn't do much good on my client, right? I mean, if my client shuts down, I lose my data, I didn't persist it. No other clients can share that information. I want to put that up in a cluster where I can share it amongst many clients. It's as simple as this. We're back to a proxy region. I can actually do near caching too, which means I can have a caching proxy. the client can actually store data. In addition to sending it up to the server, it can register additional interest to like receive information from the server that might have been generated from other clients. But at this point, I'm just going to create, it's just a shell of a region. It's not going to store data. It's going to expect to send it up to a server. So if I try to run this now, what should happen? Yeah, it should fail, right? Dope. Oh, that's that thing again. Okay, so I have Jetty on my class path, and of course it doesn't like that. Let me do one thing real fast. Sorry about that. Spring Builder. Customer client application. So there's different ways in which you can actually bootstrap, not that, client application. Bootstrap Spring Boot within your main method. You can use a builder, or you can use Spring application static methods. Here I'm using the builder so I can disable the web piece of it, which is, I lost my remote. Okay, it's right here. Okay. Now we should be able to run this and see it fail. All that just to see it fail. Boom. Okay, so what that's showing us here is that there's no available servers. So let's start some servers. All right, so we're over here in GFish now, and I initially built this as a Spring Boot application server, a cache server, but I'm not going to get into that. If you're curious to see that, it's actually part of this demo, and you can check out the code and take a look at that. But I want to just use GFish. This will be simpler for my purposes here. GFish stands for Gemvar or Geode Shell. All right, so I've already got a script that I can use to launch it. Let me go back to my IDE and grab that. And I'm just going to start a simple cluster. This is a gfish command to do that. And my script, basically, you'll see what it's executing there as it's starting things up. So I'm starting a locator, and I'm starting a server. The server is where the data is going to be stored. The locator is what helps the client and other members that join the cluster find the cluster. So it's just a location mechanism, but it provides other services as well, like load balancing, the ability to, sorry, brain fart. Well, load balancing amongst your clients and failover and that sort of thing and your pool. It's always better to actually connect to a locator so it can find the servers. Single hop capability. There's a bunch of things that a locator gives you advantage to do, as well as connect up other members. So if I want to scale up, or scale out, actually, not scale up, scale out. All right, so now we have a server running. Is it going to work this time? It didn't work. We don't have a region on the server yet. So I could use gfish and create the regions, right? But like I said, if I have hundreds of regions, maybe when I'm developing, I don't want to do that. So I provide some additional help for that as well, which is called @enable cluster configuration use HTTP true. So by default, it doesn't use HTTP, but the management REST interface in Apache Geode or Pivotal Gemfire uses JMX, and there's two ways to connect to it. You can either connect to it through JMX RMI or using HTTP. So if you have like firewalls, much easier to manage your members or of your cluster using HTTP when you have firewall restrictions. And of course, for the Spring application side to work, it's using HTTP because it's convenient, but also it's going to push this cluster configuration up in such a way that the servers remember it. So it actually takes advantage of a cluster configuration service in the Apache Geode management infrastructure to remember those schema changes. So when I add new members, they'll come up consistent. They'll have the same configuration. The entire cluster comes down. I bring it back up. They still have their same configuration. Another quick question. Will this run again? Is it going to run? Still failed. So anytime I send something between the client and the server, I need to serialize it. I didn't make my class Java IO serializable, and I did that deliberately. Now imagine, I talked about how it might be, cumbersome at first to create all these regions, but imagine if you have an entire domain model where you didn't want to implement serializable. And there's certain, obviously, caveats to implementing serializable, so you have to be careful when you do that. But if you didn't do that, you wouldn't be able to serialize your data. That's kind of a problem. But I don't want to go and retrofit my entire object model with Java IO serializable. I can actually take advantage of the serialization mechanisms in Gemfire to actually serialize that data. And one of the more pertinent ones is called PDX, or Portable Data Exchange. The nice thing about the serialization format inside of Geode or Gemfire is it's portable, meaning I can connect Java clients and native clients, and they can interoperate on the same data set. It also doesn't need to be deserialized when I query it, because it keeps metadata about your types, and it can actually access that metadata or use the type registry metadata to inspect that type or those bytes without deserializing it, which saves on serialization, deserialization cost. It's also much more compact than Java serialization because it keeps so much more metadata. There are limitations, however. For instance, it doesn't handle cyclic cycles in your object graph. So you have something A refers to B, refers to C, refers to A. It doesn't handle that. Java serialization does. But for the most part, that shouldn't be a problem if we were designing your object model correctly. So in order to enable serialization, I just turn it on. I can, of course, customize it if I need to. And providing I did everything right, it should work this time. Well, hold on. Well, let's stop it a minute. Stop. Oh, it's too fast. What I wanted to do, see, it's already there. So before I started it, there was no customers region. And I wanted to show you that it actually pushed that configuration up, but it already exists. Actually, there's another thing we can look at, but it works this time. So the application's running. And it's actually sending that data up to the server. So if I go up here and I look at my region, I can describe that region. Whoops. I see that I have an entry. And unfortunately, I can't pull that information out because the type isn't actually on the server. It's not on the class path, so it won't be able to, you won't be able to look at it. But of course, I was able to extract it from the client in gfish. So anyway, if you are confused by that, come ask me later. But the entire process of creating a simple client-server application is made easier through this annotation config. And I want to jump back over to my slides because I want to review quickly what all the different types of annotations are that cover all the many features that are in Gemfire and Geode, which are just amazing. So let's go back and take a look. All right, moving forward. Power. Yay. So we already know about the client cache application annotation. What? Weird. My buttons are off. Let's see. There we go. See, enable pools. So what Gemfire, or what the client uses, is a pool of connections that talk to your servers, right? And that pool is configurable. There's a lot of different settings on a pool, but it specifies your locators that you can connect to. That's one of the most important ones. So you can see there I got an enabled pool for a locator. Actually, that's probably not apparent from that. But you can create multiple pools so you can route your data. So different regions can actually have different pools so that they're not all sharing the same connections and not all talking to the same set of servers, which helps with efficiency and other types of routing problems. Let's see here. So we talked about the @enable entity-defined regions along with enable Gemfire repository infrastructure. The most important one being the enable entity-defined regions. We also have @region mapping annotation along with indexing annotations. That's what I forgot to show you. The index got created on the server as well. So it does two things. It pushes up the actual region as well as the index. And it's always careful not to stomp. So if you're cycling your application a lot and you push again because you've started your application, it won't blow your region away. It just acknowledges that it already exists and it leaves it alone. The thing there is you might have data, so I don't want to blow it away. And there's no options currently to kind of nuke and pave and start over at the moment, but it's really easy to destroy that region in gfish and begin again if you need to. Whoops. I'm back. So caching. So if you're using Spring's cache abstraction, you'll have like caching annotations on your services, your classes, or maybe your repository methods. You might be using JSR 107 caching annotations, recognizes those as well, inspects those annotations on your service components, and creates regions for them as well. So you might not just be doing straight up CRUD operations. You might be using Apache Geode or Piddle Gemfire in other ways. Caching, for instance, using Spring's cached abstraction, or perhaps Spring Session. They enable cluster configuration. So the important bits there is it pushes the configuration up to the server. The servers remember it when they're adding new members, or if the entire cluster comes down and comes back up, as well as it's careful not to stomp on anything that it's already done. Enable continuous querying. So if you're familiar with some of the other features in Apache Geode, Pivotal Gemfire, there's a functionality called continuous queries. I can register interest in certain events, and I express my interest through a query, an OQL query. And I can add, any kind of predicate I want, like maybe a temperature range, temperature below a certain amount, temperature above a certain amount, and just get events for that. And it's as simple as basically enabling the feature and then specifying your continuous query on some service component. Enable PDX, we saw the purpose of that, to serialize our data. There's different configuration settings there. It uses Spring Data Gemfire's mapping PDX serializer by default. Geode provides a reflection-based auto-serializer. This is sort of similar, but the difference being is that it actually uses the Spring Data mapping infrastructure metadata. And it's careful with things like if you have a transient field, it won't actually serialize that to PDX. Or if you have a property that's only readable, right? If my customer has a first and last name, and I have a convenience method like getName, I probably only need to implement that in terms of my first and last name. I don't need to implement a setter for name. I just set first and last name, and then I can call name to get the full name of the person, right? That's a read-only property. Therefore, it's careful not to try to write that back when I reconstruct the object from its serialized bytes. So there's an advantage of using the mapping PDX serializer to do that. Enabling security. I wish I had more time to actually showcase some of the neat stuff with security there, but essentially on the client, if you're familiar with how security works, you have security enabled where you need to have a username password to connect your client to the server. You need a username and password. All the annotations have well-known properties that is part of its dynamic configuration, which I'll explain more in just a bit. You can set those in an application properties file, your username and password, and Spring Data Gemfire will handle the infrastructure. Previously, you had to implement this auth initialize interface and set some system properties and stuff like that to get your client to be able to connect. None of that anymore. You also have the addition to have secure transport using SSL. And of course, everything that's left over, you can enable logging multiple different ways through the logging annotation or through Gemfire properties. There's a ton of other properties that you can set. This basically gives you a convenient way to access those. Of course, Geode actually recognizes those properties in properties files or as system properties as well. I'm not going to cover the caching server application side of things, but you can literally create a Spring Boot application that is a cache server that you can connect to. And it has a lot of similar annotations, but there's things you can enable, like you can enable the locator. I can embed a locator in my cache server and have my application connect directly to that. I can enable the manager so that I can connect gfish to it. I can enable other things like the HTTP service, the memcache server, the Redis server. So it understands the Redis protocol. You can connect your Redis clients to Geode. You can enable eviction, expiration, compression. There's a ton of things you can do. But I'm not going to get too much into the server side because I'm anxious to share with everybody something else I've been working on. And of course, some other leftover annotations. Enable statistics is kind of useful if you want to turn on statistics and use the visual statistics display tool. Gemfire writes out to a format that tool understands, and you can see statistics about the performance of your cluster. All right, so I talked about I kind of alluded to ways in which you can configure this stuff via annotations, but one of the things I wanted to preserve in an annotation was its type safety. If you're using a value that's an int, like a port, I wanted it to be an int, which basically precludes you from doing things like using a spell expression or a property placeholder to set that annotation. If you think like Spring's @value annotation, I can inject state from my environment using the @value annotation, and it uses a property placeholder or a spell expression to do that. I didn't want to do that with these annotations, but I did provide other means in which you can configure stuff. So when you see stuff like this, oh, hard-coded ports, you're going, oh, no, I can't do that in production. Well, as I already kind of mentioned, all the annotations, if you look at their attributes, have well-known properties, so you can define things this way. And the pool one's kind of interesting because at the top here, you'll see that I have this sort of generic one here, right? That doesn't have a color coding. That applies to all your locator configurations. And if you have specific pool configuration applies to all your pool configurations. If you have specific pools, named pools that only certain regions are using, you can actually specify their name as a prefix to the property. And it'll only configure that particular locator in the annotation. Okay, the other way to do it, if you're familiar with, well, here's an example of, the client cache application. Here's the locators attribute, and it basically explains in JavaDoc what those properties are, so you know how to find them. The other way to do it is via a configurer. How many people here use Spring Web MVC? Okay, a few people. So you know that Spring Web MVC has configurers that you can use to configure Spring Web MVC, like HTTP message converters, other aspects of MVC. There's probably 20 different configurers. So I kind of borrowed the same concept there. And what that gives you is it gives you a reference to what Spring Data Geode uses to configure that particular Gemfire object. If it's a client cache, you're literally getting a client cache instance. That's what the factory bean produces. This is the factory bean that basically those annotations are using to configure things for you. And it gives you, this configurer gives you a reference to that factory bean. So if you need to tweak anything, like ports, you can do that. And you can even take advantage of @value annotations in this configurer, because it's just a bean definition. That's all it is. Gives you the reference to the factory bean, and you can change your locators and so on. So, all right. How am I doing on time? Ooh. Running kind of late. Bear with me, we're almost there. What's next? Function executions from repositories. So once you move past simple use cases like caching and just basic CRUD, there's a lot of other things that Apache Geode can do for you. Function executions, distributed compute, right? I can actually execute a function, and that function executes across my cluster where the data actually is. And you can filter by keys, and that execution gets routed to those keys. Spring Data Gemfire already has first-class support for function executions via annotation support. I just want to combine that with the repository abstraction. Paging and sorting. It already supports sorting, as I mentioned earlier, but paging is not supported yet. There's a lot of Spring Data modules that do support paging, and I want to add that to Spring Data Geode. Query projections. If I have a really complex object, right? I have an account with multiple customers, with address information, all that stuff. If I'm sending that back over from the server to a client, that's a big object. That's expensive to transfer. Projections give you the ability to map the data that's in the server to a subset of that data. So I could create like a customer view that might only have the name and the account number of that customer. And that's what gets populated and sent back to the client. So query projections could help you with that. Reactive repositories. You've heard a lot about reactive during this conference. It's a big topic across all the data stores, from front end to back end and web. We have Webflux, right? So I want to start exploring reactive extensions, and I think a good area to start on that is CQs, because it's asynchronous, it's event-driven by nature, and you can easily wrap that with reactive types like monos and flux. Well, in this case, a flux. Spring Security, Apache Geode already integrates with Apache Shiro. I want to integrate with Spring Security. Annotation for other callbacks like cache listeners, loaders, writers. It's very similar to the function annotation support, so if you're familiar with that, this is essentially identical, but for other things like listeners, loaders, writers. Auto-generated IDs, I've been thinking about how that might work, because every time you actually persist something into Geode, you need to set the key or you need to set the ID of that object before you do it. There's no ID generation for you like there is for a relational database. And the most important one here is Spring-driven test context framework that I've been working on, and we're going to take a look at that. But this is what the function executions would look like. By way of example, I would just declare that the repository method is a function, and then that was how I would call it, just your familiar object-oriented syntax. Paging and sorting, so like I said, sorting supported. The new thing would be that you could return a page. That's at the bottom there. The projections, CQ extensions for reactive. You can see that I'm returning a flux there. So all this stuff is a work in progress. Callbacks for listeners, writers, loaders, transaction listeners, anything you want. Testing. People have asked me about this year after year after year, like how do I test an application? So this is my final demo, and it's really quick, I promise. Let's take a look at that configuration that I used to build this small little application. Oops. Okay, so over here, I pretty much stripped it out, so I got rid of the application class. But this is what we had. We had a client cache application. We had some entity-defined regions, or we defined some regions. We had Gemfire repositories, indexing, and PDX. So let's suppose I want to test that configuration. How would I unit test that? You could grab a mocking framework like Locator and start mocking out all the different objects that Gemfire creates. Or you could do this. So let's take a look at, I'm not going to write the test. I'm just going to show you because I know we're running low on time. Oops, already have that test. Okay. So what I have here is a test configuration embedded class. So this is going to use Spring's test context framework to begin with. So we have a run with, and we're using the Spring runner. And we just annotate that with that context configuration, and it expects to pick up a configuration class. So what I've done is I've imported the configuration that I want to test, which is essentially what our application configuration was. It matched our this over here, all this good jazz, minus the Spring Boot application, of course. I'm not interested in testing what Spring Boot's doing. I'm interested in testing my configuration of Apache Geode or Pivotal Gemfire, whichever one you're using. So in order to test it, in a mocking enabling way, when you combine those annotations with this new annotation, at enable Gemfire mock objects, if I inject a reference to any Gemfire object, a cache, a region, a distore, an index, doesn't matter what it is, what you get back is a mock object. So maybe you're not so interested in writing tests that necessarily need to spin up a actual Gemfire instance. You just want to test your configuration, unit test it, without actually starting up a Gemfire instance. This is the way to do that. So I can inject my objects like my Gemfire cache, and I can insert certain things like make sure that this is a Gemfire cache. So you can see I have a Gemfire cache reference here. All caches in Gemfire, or excuse me, Geode implement the Gemfire cache base interface. So there's a client cache instance, and then there's a cache instance for peers or members of the distributed system on the servers. So this is just a generic one, and I just want to make sure it is a client. So that's all this test is doing. It asserts the member's name, which over here in my configuration I actually named a little bit differently, but make sure that it's named correctly. If this was an actual member on the server, it would literally have to have a unique name, but I can name my clients too, so I'm just asserting that. I'm testing my PDX serialization. I'm making sure it's set to the mapping PDX serializer, that my region exists, that it has a certain name, a path, and all that stuff. And finally, I'm actually even able to save a bit of data to that region, and the mock object will remember that data. So you can do things like basic gets and puts. So if I run this test, I would expect that to pass. Sorry about all the logging. I forgot to turn Spring Boot logging down a little bit. It's spinning. There we go. Okay, so all those tests pass. My machine's a little slow right now, but technically it's really quick. And if I was spinning up actual Gemfire objects, it would take much longer. But all I had to do is add that single annotation, and it created mock objects for everything inside of my client. And with that, let's go back to the presentation and just wrap up. So Lovelace, I'm going to basically rebase Spring Data Geode 2.1 on Apache Geode 1.3. In fact, I think Apache Geode's 1.4 is just around the corner, so I'll probably rebase again. Same thing on the Spring Data Gemfire side. And again, those will remain interchangeable. So you can bounce between the open source and the commercial version and vice versa. I'm planning on making sure that that's always the case. Those are my references, and thank you very much for attending my talk. I know it's late. Enjoy the rest of your conference.